Hello and welcome to FreeStyle, where we discuss pop culture, self-help, business, gaming, and technology, among other things. We go off script here. Let's freestyle. Please consider giving us a like and subscribing. It really helps. Now, enjoy the show. Hello and welcome to FreeStyle. I'm joined by Turtle.
Hello.
And Andreas Metzen.
Hi, folks.
How's it going? A couple of topics today. It was introduction background to orchestrated object reduction. That was one of them. Emergence of quantum physics. Building blocks of the brain. Consciousness and evolution. So there's just a couple of things. I guess just introduce yourself again for anyone that's never watched any videos here, Andreas.
Yes, sure. So my name is Andreas Metzen. My company runs by the name of Capo Momentum Advisory. I recently, I wanted to say opened a YouTube channel like it's a store. So I set up a YouTube channel called Seize the Moment and talk about a range of things, one of them being astrophysics and cosmology. And that's what I came back to be a guest here to talk about consciousness in our universe and a bit about OR, and I'll explain in a second what that is. So yeah, that's me in a nutshell. I'm located actually in Germany, so forgive me any mispronunciations of difficult words that I probably wouldn't even be able to pronounce in German. So if I mispronounce, I'm sorry. Don't shoot me.
Oh, you're good. I think your English is a lot better than most people who actually speak English, so you're fine.
The title of the lecture that we're kind of going to scratch on and maybe go in depth in some places here. Like I said, I gave this a couple of years ago. I think it was, let me see, 2019, and two times I gave it in 2019. I was a member of the local observatory for about 6 or 7 years, and I gave a couple of lectures on different topics, but let's not go there. So in 19, I gave this lecture, and it was around consciousness. What is it? I was always curious about understanding consciousness better. It's a big scientific field, actually, that's been growing, and also a field in philosophy. And there's these gentlemen here, Stuart Hameroff, which we briefly touched on, and I mentioned Sir Roger Penrose. And the guy on the left is a biologist, and the guy on the right is a physicist. And they have together come up with a theory called orchestrated object reduction, so short OR. And it appears to be explaining where consciousness happens, and that's in the microtubules. And the nature of consciousness appears to be a quantum mechanical effect. And I will talk maybe a little bit about what that means. So Penrose, who's the physicist, actually came up with this using quantum gravity. So gravity's effects on quantum levels, so very small, material-wise small, and so to say, it's not correct what I'm saying, but very small quantums. There's also gravity effects on it, and that's where that creates consciousness, so to say. And the two of them claim that consciousness does not arise from the connection of neurons, but is controlled by this molecular structures, the microtubules. So hence this comparison to computing power of neurons to microtubules. Given that consciousness cannot be an illusion, and we'll talk about that a little bit maybe, because there are some theories or philosophies that where you could say, well, consciousness is just in the brain, it's not really out there, so to say, and it's just an illusion maybe, and that seems not to be the case following this theory. The orchestrated object reduction basically means it's controlled by the structures of the brain. So that's where the orchestration happens, given the structures of the brain. This objective is because it's based on rules of quantum gravity, and the reduction bit is because there's something called the collapse of the wave function on the quantum level. That's, for example, if you observe a quantum state, then the mathematical function, it's a mathematical function basically, that is called collapses. And then you, in a way, reality appears, I would call it like this. So that's where the reduction comes from, the collapse of the wave function at a quantum level. So if you never heard about quantum mechanics or quantum level stuff, I'll call it, then this is all going to be like, okay, so maybe I'll take away from this. There's some biological structures in my brain where consciousness seems to happen, and there seems to be some quantum computing going on that creates consciousness. That's maybe if I say it differently, more simply, maybe. The theory actually reaches in an unconventional way across many fields. So general relativity, quantum mechanics, and also neuroscience, cognitive science, and molecular biology and philosophy. It has impacts across the board, as has the topic consciousness. So that's not necessarily just because of work of art, but if you talk about consciousness, and then you have to, I think that's where you actually cross over all these fields automatically. And that's where I also think it's, if you can't unify, so to say, these areas, then you probably haven't explained biology, but not biology, but consciousness really well. So you need these bridges across these different sciences, so to say, to, in my view, to be correct and to find the right answer. So just quickly, Saroj Penrose, he just turned 92 in August. He's still sharp as a Japanese katana.
We can't say that about our president, can we?
Yeah, he definitely talks more coherent than the current president. But yeah, he's a physicist. He has worked with Hawkins, for example, and he received the Nobel Prize, I think, 2 years or 3 years ago. So well-known professor, well-known physicist. This is not some, I don't know, new guy on the scene here to say. So very experienced physicist. Hamroff is 75, so he should also be really retired. He's actually American, lives in the US in Arizona. Like I said, anesthesiology is his field. He puts people to sleep. And for many years, I think it's in early decades, he's been interested in understanding consciousness. And just a side note, there is, and that's actually in here too, there is actually, and I find it super interesting, and I haven't watched the last couple of years worth of videos, so to say. There is conferences on consciousness, so to say, on non-duality. There is conferences going on every year, and I find this whole field as an overall really interesting. So to keep it short on the background of the lectures, I use material from Hamroff and Penrose basically, and I have here and there, and Penrose has written a couple of books. Can recommend it if you can dry read, if you like dry reading, so to say. Then you can go through this also. Well, it depends on if you're not interested, then I would just say look.
Yes.
Yeah, I mean, I've cross-read them, and because he gives quite condensed compared to a book, maybe lectures, and I named them here, and I looked also at the paper. So I tried in this lecture, and we're not going to go through the whole lecture, don't worry, because it's going to take too long. I tried to condense it ultimately for myself, and then that I could also talk about halfway intelligent to other people, because it's like Penrose's lecture is about 2 hours, Hamroff's is about 2 hours. And they touch on certain things, they touch all their stuff in detail, and I actually had to kind of cut here, cut there, and condense to make sense of it. I use these two books. I have some stuff in here, graphics that they have to use some things about, or to explain some things with some graphics from relativity and quantum theory. I like the books because, some of the graphics were just easier to understand. So we talked about this. So quantum physics, or classical physics, is worried about local objects or things and particles. Where in quantum physics, you have things that are called, and I explained some of it. Hopefully, I can explain well enough. Something called superposition. It's non-local because you can't, the wave actually, or the particles don't seem to be. You can't pin them down. You have mathematical formulas that explain or that show actually that particles can act like a wave. That's probably a good way also to explain quantum physics. And then you have these wave functions, mathematical functions, or mathematical probability representations. And the quantum world is small. So, the Planck length is, I think, 10 to the power of minus 35. So we're talking smaller than you can see through a microscope kind of stuff.
That's tiny.
Yeah, it's
And
smaller than apparently the human brain can even calculate.
Yeah. Yeah,
Essentially.
and that, and interesting comparison, but yes.
You can't even understand it at that point. There's no understanding.
And the key thing, and I guess I can I will hop over maybe prime examples of classical physics. So you have Kepler's law. So Kepler was a gentleman. Here you can see the time they lived was the 16th and 17th century. So, and if you think about it, how long it took humanity to get to that level, and then how long again it took from, let's say, 1570, well, let's say, when did he write it? 1619, so the 17th century, up to like Einstein in the 20th century to make the next step, so to say. So Kepler looked at also one of the things he looked at was planets and how they move, and he came up with formulas of how to explain the movement of planets, so that the sun is in the center, it's an ellipse and not a circle that they travel in, and that you have math, so to say, around that. Then you have also Isaac Newton, Newton's laws, one of them being about there's gravity and two objects, depending on their mass, pull on each other, so to say, given their gravity, and then you can calculate that force. So the whole thing about explaining there is something, and they call it, or it's called gravity, that pulls on it, without being able to explain, like Einstein did later, what it actually is and how it works, but it was able to calculate. And then Maxwell explained things around electromagnetic fields, so to say. Those were this is like classical laws of physics. And if you see, I'm trying to estimate here, so it's like 200 years worth of physicists' knowledge, so to say, together. But then problems came about that, like they always have been and probably always will in physics. There were topics or experiments that couldn't be explained. And I won't go in a great level of detail here, but examples are, if you look at Mercury, so the planet Mercury, it shifts its, and I hope I say this right now, perihelion, so the position that it's closest to the sun. And this is the graph. You see my mouse pointer, right?
Yes, sir.
Yeah. So
I also wanted to say, by the way, you see my camera on the bottom spinning. The way I'm linking my camera in OBS, I may have to re-record not anything that was said, but just the slides you showed in the beginning, just to have them for the video. So I'll edit this out. But my camera is spinning, but I've already replaced it down there in the bottom. So I just don't want you to be alarmed. You're like, oh, I'm talking to nobody. Like, because you can't see me, I'm here, but it will show up in the video. But it's just the way that I have to display it. But anyway, continue. Mercury, perihelion, my bad.
Sorry, Mess. You're really passionate. I appreciate it. I actually have a few questions. Of course, I'm not looking for a definitive answer, but perhaps you might be able to clarify some things for me.
Sure.
Okay, so in regards to these microtubuli, sorry, I'm just trying to understand in which category do they belong in? I understand that they're on a biological level, but in which realm? Are they a quantum physical realm or a classical physical realm?
It's a great question.
Can I
Well, I know they're
turn
a
on my
physical element. I know they're like an
can I
actual physical
can,
thing.
okay, I'll answer the question and then I'll say I'll give you more details in the back of it, and I can speed this up. I understand maybe you don't want to see this right now. The microtubules are actually structures. They're actually proteins in cells, in T cells, neuron cells, and I'll talk about this where they actually are located. So it's in the brain, physical structure, protein structure, and they appear to have. I think I heard my camera go off.
It seems like none of the cameras are working right now.
No, no, they are. They are. I
Oh,
just
are they?
yeah, my camera's on and I've already put it. It's just going to be over top of the little spinny thing. It's the way I have it in OBS. That's the way I can switch scenes and do other stuff.
Gotcha.
I guess I'll need to have like a separate OBS build just for recording video. Anyway,
Right.
it's
So the microtubules are proteins.
Yeah. If you have patience with me, I'll try to be done with the physics here in 5 minutes, and then we'll jump into it, because then I explain stuff that comes a bit in the back here.
Got you.
So I'll be high level now. So if it's too I'll try to speed up, and it's difficult. So I'm just what I'm trying to achieve is give a sense for what's quantum physics and where did it come from, then to maybe better understand the quantum physics things of side of things, so to say. So classical physics had problems, so to say, and there's a couple of experiments, and I think these four are the most predominant. The perihelion of Mercury shifts every so often, so it moves, and there was no way to explain it given the laws of, for example, Newton. You had issues with the black body radiation, where it should technically, given what they knew back then, you should actually have what was called an ultraviolet catastrophe. So it should actually, the energy should have just been mad in this experiment, but they couldn't explain it. In the photoelectric effect, where you shoot light at a metal surface and it kind of pushes out an electron, that was also difficult to explain. The Rutherford model of an atom, where you have a nucleus with neutrons and protons, and the electrons spin around it. Given Newton's laws, you would have to have some energy come in for them to be able to keep orbit, so to say. So that didn't help, and then also the shift of it wasn't. There were some things that were not making sense. And also these that you can see when you send light from a black body through a prism, and then you have this continuous spectrum that we also know from the rainbow. If you send a hot gas like helium gas or something through a prism, then you all of a sudden see these line spectra, respectively absorption spectra in a cool gas, so to say. So there were a couple of things that you weren't able to explain, and the answers are in the way on the bottom, and some of the gentlemen that were the main contributors, but it's not all. You have to be always clear. These gentlemen also worked amongst each other. So space-time curvature, Einstein, that explains the perihelion topic, that space-time is curved, and that's why it shifts. What I explained earlier, that you have to quantize, is that a word? You have to put energy into quants, so to say. So into chunks, like a cake, you cut a cake, and that's how it works. So having these chunks needed it to explain this black body radiation problem, so to say. Same for light, and then the quantum leap of Bohr, is that the electrons actually jump if they're irritated, so to say, from the outside, on certain levels, so to say, and it's not they don't move smoothly across. They jump on different is it radii then in Latin plural across. So you had these classical physics not working anymore, so to say, and then quantum mechanics, so to say, was created, and it was created in three ways. There was matrix mechanics, wave mechanics, and transformation theory. all from well-known physicists, Heisenberg, Schrödinger, of course, and Dirac. And they explain things, they're all valid, respectively, and the one that kind of, I don't want to say stuck, but that is the focus, so to say, here is Schrödinger's equations that show this quantum world in a mathematical way, and as in something called a wave function. So it's a mathematical representation of these effects, so to say. There's interpretations of these formula, so to say. You may have heard of many worlds interpretation. So this is, and there's still folks today actually saying, if you have these quantum effects and you have where the quantum world has to decide in this way or the other way, given certain states, that each time that happens, another world is created, so to say. So they say there's never collapse of the wave function. So when you have, when the universe needs to make these choices, and big or large, every time there's a new world, and then you have this, I'll use Marvel terms, multiverse, that then change. It's still a used explanation for quantum mechanics. I don't think it makes sense, because you have this constant 10 to the power, I don't know what, new worlds creations. This doesn't seem to be mathematical. It may appear logic, but I'm not a big fan of it. And then you have the Copenhagen, because that's where they were, Heisenberg and Bohr, and Born and Pauli, and they came to the conclusion that if you have a system, if you have a quantum system and you measure, then these probability mathematical functions collapse, and then you have a specific measurement. And this may be a little bit too theoretical. So a well-known example is the double slot experiment. So if you send like a photon laser, like in this case light or laser light, through a double slit, then at the display here, or the how should I say, can't come up with a good word now, the wall on the other side, in a way, if you have just a double slit and you don't do any measurement in the front here, so you just send it through, you will see that, that's what's shown here, you will see that it looks like a wave pattern. So the waves of the light, what, and it was in a way known, or this is the experiment to show this, light can be acting like a wave. Then you have a pattern that looks, like a wave pattern. So you have these mountains.
Those were photon receptors on the other end of that screen. That's what they were, photon receptors. And they showed a pattern. They were like dots. So there's all the receptors for but it looked like a wave, like you're saying.
Yeah, and then if you actually measure here at the slits, where does the photon go through? So say the individual ones. Then all of a sudden you get a either or dot on the other side. So that's kind of a dilemma. Why is it okay? It can be it can be a wave, and it can be a particle, where it just goes through. And at the time of measurement, then over there, then it kind of decides. And that's in a way you have this probability. I have a video, but I said I wanted to be swift about this. So it comes here as a wave.
We've seen this. I think a lot of people are familiar with this. Let's move on to something else.
So that's that. Then you have this classic experiment of there's you have.
Are we still in the physics of it? Because we hadn't gotten back to where we're getting to the other part. Okay.
I can jump because of the experiments. Let's go. We've seen this. So you have maybe just these statements. And sorry, there's still German stuff in the slides here.
That's right.
It's very interesting, actually.
Quantum physics is a statistical theory. So you have math under it, and it explains things that are happening from a statistical point of view. And yeah, I'm not going to go through this maybe to avoid over. So I talked about the wave function that's going to be relevant for the stuff that's coming now, the biology and the physics side from Penrose. So the wave function is a mathematical abstract function. So it's not real, so to say. It's just, trying to explain the world in a mathematical way. When you do the measurements in these quantum states, then that becomes real. And for this superposition of these states, because like in the photon going through the slit, it could be there or there, then that's reduced to either or, and that's the reduction, or it's also called this collapse of the wave function. So it's this decision point, so to say, in this case in the experiment, when there is a measurement, then the math, so to say, creates the wave function collapses, so to say, and then you have a result coming out of that. That's in a way, I'm not sure if I explained it well, but that's the whole point about when it says, the wave function collapses, is in a way, okay, the system has to decide now, left or right, so to say. I won't talk about this. I will talk about briefly just about this. There's been experiments, double slit experiments. I find this weird and cool at the same time. So you have an observer, or actually you have the same experiment. You have, a double slit experiment here to say, and then you have in another room, you have a meditator or somebody who's just contemplating on it. And you tell them, focus on the double slit and try to feel, or, what slit the photon will go through. And it actually changes the result as if you were measuring.
Mm-hmm.
If you can believe it or not. So this is like different room. Person is just focusing. He knows there's the other room. There's a double slit, and the person is just focusing his concentration / his consciousness on this. So that's strange. The results are there. The studies are there. You have,
Wait,
other people
someone thinks about where it's going to be, and then they measure, and that's where it was?
No, the
act of measurement makes it be known where it is.
The act of concentrating on it makes it not behave like a wave anymore.
Wait, when you're saying concentrate or actually measure it?
No, actually just like the little thingy, the guy sitting here in meditation pose, but really just focusing on it in a different room, not actual measurement. They're just doing the experiment. There's nobody in the room.
Because that's weird, because I understood the measurement of it. It had almost something to do with just you seeing it, like the light, the way, like putting light on it. Literally, light changes the outcome. Like it makes.
So this is not.
Whereas this has nothing to do with you even looking at it at all. There's no detection physically. You're just thinking about it in another room. Got it. Okay.
Yeah. So it's not. There's no electronic or a device measurement at the double slit. It's literally just somebody sitting outside the room trying to focus on that double slit. And then you get these results where you see it actually changes the effect. And the most craziest thing is that it actually works over distance. So people in Europe or Asia or in the US, I assume, is here. So even over distance, you have an impact. So that's completely crazy to say. Something. So Hamroff talks a little bit about consciousness and where it comes from. So where is this being, what he calls in his presentation? Where is this appearance of consciousness? Where did it come from? Did it happen? Did it happen here in our very beginning of time, or already at the Big Bang? And I'll be a little bit swift about this. So in neuroscience, psychology, and Western philosophy, it's the usual interpretation would be that life has made consciousness possible. So in our consciousness that's focused on the humans, it's only the human brain that made it possible. And then you can talk about animals, of course, before that. So you needed living systems to have consciousness. Then you have panpsychism, which I believe is a philosophy, Eastern philosophy, so Buddhism, Hinduism as examples, and others, and quantum approaches, and those state that consciousness is intrinsic in the universe and it precedes life. quite an relevant distinctions to make or area to think about. So do you have Plato here? For him it was the being, the consciousness was just in the head, not necessarily out there. There's this Plato's cave parable where you have a prisoner who just sees in the frontier, he just sees the 2D world. There's a wall behind him with light. There's guys, other guys with puppets here making it, and then all he sees all his life, he's attached to this pole, and then his reality is two-dimensional, so to say. And you have to. This is stuff that humans have had to go through to think about, and this quite honestly even discards idea of, okay, well, maybe my brain is somewhat, in this experiment would be it's in in some soup and it's actually controlled, and then it's being fed from outside. You could also have a philosophy like this in Buddhist or Eastern traditions. Consciousness is present everywhere. So now we get to the brain and to the question that Terrell just had in a way. So the modern science describes the brain as a neural synaptic computer. That's the maybe not mainstream anymore, but still that's what I would call mainstream. So you have this synapses and neurons, and it's a network, and that's how brain computes and has. Now there's something called a roundworm, a very simple creature. They actually documented the synapses because it's small. They can document it, and then they created a model of it in the computer. That's what's shown here on the right side, and the expectation was maybe, okay, now we created this, we simulated this worm in terms of the synapses. Shouldn't it now be able to do the stuff that the actual worm can do? And no, it didn't. Something was missing. So if you make something simpler and smaller, like, by the way, I wanted to just check something. Yeah, it's fine. You have this slipper animal, paramecium, sorry. Very simple structure. They can learn, they can avoid enemies, they can find food and mate, but they have no synapses. It's just one cell. So that's intriguing. It's like, how does it do that? If you talk about synapses being relevant, it has only one, but it can all do this quite complex stuff already. Like learning, avoiding enemies and so forth.
So it's a one cell, and it has, but it doesn't have a brain, right? So
yeah, but it must have something,
right?
and the something is if you look at the paramecium already, you have these structures in it, the cilia, and the top left is the paramecium, so the actual cell, so to say. It has these hairs like projections called cilia, which are also located in our lungs and in our gastrointestinal tract. And they consist of duplicates of these structures called microtubules. So you have these duplicate, it says here these doublets of microtubules. And the cilium protrudes from the cell and is both a sensor and a motor. So it bends back and forth, and so the paramecium advances and floats. And this is a centrulate that organizes the division of the cells in the nucleus. Any case, so they also consist of microtubules. So how do the cilia do this? And the answer, the cilium bends in the following way. The microtubules shown here have these motor proteins called dynein. Not sure I say this the right way. And dynein arms, and they contract, and they use ATP, endothine triphosphate. When I go into this, and that's how it bends like an arm, and then it can move. And they cause the whole cilia to move back and forth. And with that, the paramecium floats around. And when it hits something and the cilium is bent as a result, a signal is passed into the interior of the paramecium. So this movement, and it hits something, there's a signal sent, and it knows where to go and what to do.
That's interesting because, the word mycelium network, I talked about mycelium, the cilium, very similar words. Maybe this is, it's probably Latin or something, meaning something.
Maybe.
I don't know. But, these, it's interesting. These fillers, it might, it's going to sound really nerdy or weird, but that's kind of why animals have whiskers on their faces, like cats and stuff. Like those are used for a lot of things to interpret the world around them in some ways, be it by feeling or what have you. So I don't know. Interesting stuff.
Yeah, I mean, in terms of sending a signal, yeah, it's the same thing. But if you look at how you have these, microtubules inside here, and they are doing something. And now you could, of course, ask, so what does that have to do with our brain, so to say? So if you look at a brain, that's the structure here on the left. You have a neuron, then these pathways out, and the main pathway, an axon down here, and these dendrites. And it turns out we have exactly the same system of this dynein motor protein, which is used on a microtubule in our brain neurons. So the microtubules transport this dynein, you see it on top here, along to move it to a synapse that could be, say, for example, out there on the top right. And this is how the stuff that is synthesized here in the neuron is transported. So I can't talk very intelligent about the whole chemistry around this. If you look at this little video, it looks, it's actually what's happening in a way. You see this these little proteins transporting stuff. But let's maybe come down to these. This is actually what's going on. I'm just going to play just a second. It's not a very long video anyway. You have this chemical, biological motor proteins kind of moving like this around and transporting stuff.
It's like a Disney animation, like way he's walking.
Yeah, and you see it goes along this. If I go back, it goes along this microtubule as a thing. So there's a connection in terms of chemical things, I would call that, happening on the microtubules.
Okay, so, are these all floating around in some kind of mucus or something? Like, how are these things? Like like an ant carrying a giant leaf. Ants are known to carry things 100 times size their times their mass. So, like, what is this? How is this all going on? It's crazy.
So if you see this graph here, you see that there's actually this magnifier here, and so it shows you have this structure here of the neuron. This I'm actually not sure how to call it. Dendrite, it says here. And it just shows what's happening on top of the microtubules in this dendrite, of how information is, so to say, forwarded chemically, I will say.
So I'm just going to ask a question here, just for the sake of my understanding. So the microtubule, the thing that's walking, is carrying that thing. What is it carrying?
It's actually not the microtubule. It's actually the light blue stuff here. So it's actually bridge. on top of this, the other, I will be a little bit generic. Forgive me. It's the like the dynein and the kinesin and the taus walk along. That's how information is processed, so to say.
They carry it like little messengers from one place to another.
So microtubule is that bridge there, the blue bridge.
Right. And that's just I think it's just trying to show how other information is transported. So maybe just the model on how's consciousness happening, so to say. And you have this three-step path to consciousness. So there's regions of the brain, the cortex, the thalamus, I hope to say this all right, visual cortex, and first the signal goes to the primary visual cortex, so to say. That's the arrow 1 here that goes over. So if you see something, Play-Doh here as an example, you have light coming in, it goes to the visual cortex. But that's not the actual consciousness part. So Christoph Koch, that's an American neuroscientist, showed this a year ago that that's not the consciousness bit of it. Then the signal is sent to the front of the brain in a feed-forward mechanism. This is arrows 2 going to the prefrontal cortex, and this is also not consciousness yet. And then there's a third wave that projects different areas in the prefrontal cortex. Those are the arrows red in with the 3 on top of it. And that's where you would actually find in the brain consciousness. So the whole process takes only a few hundred milliseconds, and it correlates actually with the gamma, but I think that's maybe too technical, gamma synchronous EEG frequency above 30 hertz. That you could measure with an EEG. So that's the process. So the answer is, where is consciousness actually happening, so to say? It's in the prefrontal cortex regions of our brain. I think don't have to talk about this. So now we're getting closer to an answer on Turtle's question of where is it actually happening, and then maybe how. So you have this signal processing. So once we reach the prefrontal cortex, there's also 3 waves inside, so to say. The input from the thalamus reaches level 4. So I should maybe explain, there's levels inside a pyramid cell. So this is the structure of a cell, a pyramid cell, so to say. And there also you have it. Don't have to go into much details. It flows also from there to there's different waves. You see this 2, 3, 1, 2, 3 up to level 5 in the subcortical output, so to say. So that's just mechanism on where it shows here. So let's go over here. Maybe skip this. So you have this pyramidal cells and microtubules. And that's where inside there is where the magic also happens in this microtubule. That's where they're located. So in these neurons.
They're like little processors or something.
Exactly. So you see there their symmetrical structure. There's still some German on here, apologies. So there's these there's 13 protofilaments, and those are themselves, so the A's and the red and blue, they're alpha and beta tubulin dimers, I'm sorry. So the whole thing functions like a quantum computer, where these sections, these we call them the dimers, could be in different states. So Hammers was first interested in microtubules when he was studying cancer at the medical school, and then he studied mitosis and how abnormal mitosis could lead to abnormal or to genotypes or cancer, to make it more simple. And this theory of cancer due to abnormal mitosis is actually making a comeback now. So computers were new at the time when he looked at this, and it was discovered that microtubules were in the neurons. So microtubules are part of the neurons. So he began to think that these microtubules could be computers, and then modeled them. And that seems to be what they're doing. I won't go into long-term memory, but then to say it simply, the microtubules also seem to have a role in that. I'll skip this. So that's a very simple way. There seems to be that memory is printed on these microtubules in a mechanism. I'll just keep it at that. That's kind of what you see, this thing coming, and it kind of stamps a memory on it, and then it moves on. And that's how memory seems to work. So basically, you have these microtubules that can act like a quantum computer. I'll keep it at that, with bits on and off, and so to say. And then you get to the point of where we said, okay, what's the computing power of this in compared to neurons? And we talked about this in the beginning, where it's a power factor of 11 greater when you consider the numbers of microtubuli in the brain. But then the big question is, okay, but where does it come from?
Where is
How
the
do you explain
Bing?
it?
Where is the
Yeah,
Bing? And what is the Bing,
where
by the way? I'm seeing these on your slides.
yeah, exactly. Where's the Bing? And then Hammerf was actually reading, I think it was The Emperor's New Mind, from Roger Penrose, where he talked about consciousness and was looking for, so to say, at the end of his book, maybe there's a structure in the brain that could, where we could put it, so to say. And then Hammerf contacted Penrose, and they, yeah, formalized, so to say, their theory. Bear with me, my camera turned off. So now comes the interaction between, okay, you have these microtubule structures in the brain that act like a quantum computer, but how does it function? How does it work? So we talked about the quantum mechanics or quantum physics. This Schrodinger's cat experiment or thought experiment, I should say, is that you have a photon that either is or is not reflected onto here, and then depending if you look, then you would know if the cat, and then if it is a detector detected, then it triggers a hammer that releases the poison and the cat dies. To formulate the whole experiment, and then if you don't look inside, so to say, you would know, but if you look, then you would know, and so you have the superposition of a dead and alive cat. That's why it's this Schrödinger, I think, meant to show how that you get this absurdity, so to say, that you could have the cat being dead and alive, and pointed actually at this. I won't talk about this. So let's get into the physics side of things in this. So Penrose then said, okay, he proposed this objective reduction based on quantum mechanics. And you asked earlier, how AI should be to be competing with the human brain in terms of consciousness. The big difference is understanding. And Penrose goes into great details explaining how understanding is more than something that can be calculated, and you actually need the collapse of the wave function for it to work. And this superposition is then the separation and this underlying reality. So
now can you explain the collapse of a wave function? How is the collapse of a wave function how you have understanding?
So if you take this experiment where you have, this photon coming in, and it either goes through this mirror, or that's what it shows here. Either the photon goes through the mirror or it's reflected, and then if it's reflected, then it would trigger the hammer, and then the poison is released and the cat will die. So you have this superposition of states being it went through or it didn't go through, and then the result would be dead is cat or alive still. And if, let's say this is a box, that's why it's shown here like in the box. If there's no conscious observation, then given Schrödinger's equations, you would have this superposition state. And the collapse of the wave function of the probabilities, because there's probabilities for the cat being alive or dead. So the collapse of the wave function is actually this choice, where, let's say, we would actually open the box and you would see, okay, it died, or no, it didn't die.
So
that's the collapse.
So the collapse is before you actually check, or is the actual checking or measuring the collapse?
I would say it's differently. I'd say that's when reality happens, so to say. That's where the math stops and the actual the system has to decide, like the photon has to decide, which way did it go now. So the collapse is where the superposition, so these two states, the universe, so say, if I say like this, has to decide, well, which one is it, left or right? Does that make sense? Mm-hmm. A little bit, maybe, I hope.
It sounds like doesn't matter what choice we make, it almost seems like our fate is in the hands of something else. That's just based off of this Schrödinger experiment or the theory or whatnot. It's really, it seems, that's what it sounds like to me, because like you mentioned, left or right, and the universe has to decide, or some greater intelligence has to decide, which I don't know. It sounds it's interesting. I still have a lot of questions, but I'll hold my questions until later.
Yeah, so the something is actually the quantum gravity pieces of it. So that something is that quantum gravity will ultimately have the impact. That's the whole objective piece of it. That would be the answer, so to say. So this is already kind of a summary, so to say. So the object reduction piece of it, each collapse of this wave function in his theory creates what he calls proto-consciousness, and I'll explain how he goes about explaining it, so to say. And like I said, if you want to have understanding like a human is able to, and we can talk about animals as well. So this intelligence, or not intelligence, but this awareness and this understanding, you cannot calculate that. So given this, if the collapse of the wave function causes consciousness, then each such objective reduction event is characterized by a subjective experience. This being that's being used in the lecture there. And now it becomes maybe a bit difficult. You have something called qualia. So what's the color of red? What's the color of blue? Basic level of information, as I would call it, or here it's called Platonic values. And these examples were now examples of, how do we perceive light? So, for example, so it appears overall saying that consciousness seems to be a process in the structure of the universe. That's already the summary of it. And to maybe keep this simple, and Penrose does a great job of actually taking this whole topic apart about can understanding be calculated? Because that would be the attempt using AI, for example. Yeah. And there's chess examples that an AI wouldn't be able to solve because it's missing something. There is geometry puzzles. I'm not sure, do I have this in here? No, I don't. I left all this out because he goes into quite some length. Geometry puzzles where you give like certain shapes and you try to tile a plane with these shapes, but you cannot really calculate it. You actually kind of have to understand, and then you could tile it to solve the puzzle, so to say. So there's clear indication. This is also based on physics and Gödel's theorem and other things that he brings up, where it's quite believable as far as I can wrap my hands around it, that you can't compute certain things, which would, the argument about AI, for example. So that's not possible.
You're saying you can't compute certain things, as in you have to use instinct,
or understanding,
or maybe a greater understand like more logical thinking or abstract thinking.
Consciousness in a way what we are able to create with our consciousness, this bit of awareness and understanding. That's what you
could almost need. Call it luck in a way, in some ways too, like when you kind of have a good understanding of a system, whatever system that may be. Would be if you're a good foosball player, or if you're good at 3D printing, or if you're really good at shooting basketballs. You've got a good understanding of something, and I think luck does kind of tie into it. But anyway, I'm kind of going off track a little bit.
Yeah, because you would be like, if I would give you this, take this chess, thing, then there's a mathematical way to calculate where you can have like Deep Fritz is a software. I'm not sure if it's the latest version here that shows 14. You can have a computer, run this and calculate, and that computer will calculate based on algorithms that were programmed, but it's not able to look at the problem and just say, no, this is actually either, a draw, or actually a white can win, and it's just this type of, and it's, like you said, also in this case, not luck, but it's about, a different level of understanding that you cannot calculate, for.
It's so true. They're like white can win if the king just takes the pawns and lets the pawns get hit the edge of the board, become queen, and then so on and so forth.
Yeah.
But yeah, it's it's interesting. I mean, I have so many questions because like I feel like this still does not quite give me a satisfied answer, or like it still doesn't satisfy the question of consciousness, because like earlier you mentioned that Penrose, I believe it was, he was like one of the people who discovered microtubuli. Is that correct? Am I attributing
Ha-
the discovery to the
Ham
right person here?
Hammroff.
Oh, Hamroff. My bad.
Yeah.
Hamroff. So
Yes.
he discovered these microtubuli, and then early on, I think it was his quote that he said that these microtubuli creates consciousness. And so when it says creates consciousness, that gives me the impression that he must have somehow studied the consciousness being created, the effect of consciousness through these microtubuli. And I'm just trying to understand how did he measure this? Like in what technology or in what fashion, or like how did he say this, like he was able to say that thing that this microtubule just performed, this action just created consciousness. So I still feel like there's just too many holes here.
Okay. I will close the holes I can close with the rest of it, and I'll try to wrap up here in the last 5 minutes. And then I think that question is answered as well. The answer is if you take Hamroff, and I'll try to answer the question and go to the rest. Hamroff is an anesthesiologist. So if you put somebody to sleep, so if you make him lose consciousness for an operation, because they got to cut the patient open, they use anesthesia, and they are now just doing experiments on single microtubuli to see if anesthesia makes them stop working, so to say.
Mhm.
So that points to proof of, is it actually happening in those microtubuli?
Consciousness is what you're saying.
Because if the anesthesia knocks out the microtubuli, then that's where it is in terms of locating it, right?
So if it knocks it out, how does it recreate it? Because like it still doesn't make any sense. Like it has to draw from some source, like in order to
Right.
create consciousness.
So
my-
what you said about it, the microtubuli per se is not creating it, but their quantum state and the collapse then creates the consciousness.
Well, it also
so
memories.
The quantum state. So it's like I believe, I think it was like early on, it was like 10 to the power of negative 35 or something along those lines, like something that is just so small to measure, like these quantum things. Like I'm just wondering, how did they measure? Like how did they measure it or draw it out? Like using what technology to like underneath the microscope? Because like to me, it's like there has to be some form, some source, right? Like to me, it doesn't quite make sense.
Okay. Understood. I would park that because it's I believe what you're looking for is in here. So let me just. I don't think, or am I in terms of my slides? Yeah, I can wrap up the quantum stuff of it and walk through it. And then there's actually that's in the chapters with the real appliances and the actual experiments, and I think it answers what you're looking for.
We'll see.
So yeah, maybe not. I mean, I'm sure, and there will be. I'm not claiming to be able to answer all the
theory
questions.
still, so I'm sure there's lots to uncover.
Yeah, it's not.
Course, yeah. Like
Yeah.
the thing, what I'm learning here is that there's a lot of technology that houses certain powers. Like it makes a lot of sense. My question is, or the answer that I'm still looking for is the consciousness, because it sounds like the microtubule like doesn't necessarily create consciousness, but it houses it.
Yeah,
And
stores
so
it
if you're able,
like memories.
yeah, like it houses the consciousness, but like as soon as you put anesthesia, knock the person out, it's like that housing has become numb. Kind of like, when you freeze your hand, you can't quite make a grip anymore because it's frozen, right? So I get it. The blood isn't flowing through the hand anymore. But you heat it up, and obviously, the technology of the hand, like, you can start moving it again, the muscles start functioning, the blood flows through, right? But it's like consciousness, where is that? Anyways, we'll continue. I'll hold my questions.
It actually the microtube was actually created. So because they're kind of quantum computer, and I didn't even talk about the overlay now, because I was trying to explain just the biology side of Hamroff, and we didn't go into yet. Okay, what is it on the quantum side, and then how does that work in the microtubule? So that's actually coming still. I hope I can use his slide intelligently. So these are slides actually from Penrose. Since he's 92, he actually still uses slides, if you know what a slide actually means. So plastic sheet that you write with a permanent marker on, and then you put it on the projector like it used to be in the quote-unquote old days. In any case, that's, yeah. So it's cute to see when he's there with this little, I don't know, 20, 50 slides, and then he throws a, anyway. So on the bottom left here, you have time, space, and of course this is not a good depiction because it's two-dimensional, and actually space is 3 dimensions, and you have time, but for the sake of this, it's easier maybe to understand. You have this space-time.
Looks like a branch too, like where something's we go
right,
off one
so
direction and then another.
So you have a
proverbial fork in the road.
Yeah, the top here is in the way the experiment from the cat. You have, light coming through a mirror, and it either gets reflected or it goes through under quantum conditions, so to say. And then if you look at this in terms of, okay, let's take a look at this. This is the W up here. It could flow here or it could flow the other direction. And then you have a distance between those two, and he argues that, okay, if you have this, then gravity still works also in these small distances. So what I said earlier was actually correct. 10 to the power minus 35 is a Planck distance, and Planck time would be 10 to the power minus 43. So if you have this, gravity works. So he says that at a given time, quote unquote, the universe perspective, you can actually calculate this. It has to collapse. So the superposition of it could be here or there has to stop, given a certain formula, so to say. And when it does that, it's the same graphic here. Then in the many worlds interpretation, you would have this. Okay, if it can decide, then you would have this multiverse in Marvel's language. You'd have, each time this happens on whatever scale you're talking about, you would have different universe pop up. Okay, that's not very satisfying. And you have these two, options here. It's the same graphic still, just shown differently. Yeah, it could be left or right. So you have this superposition. That's also maybe a good graphic to explain the superposition. So it could be there or it could be here. So which one is it? So you have a space-time that's actually curved. So there's gravity, while maybe small, it's working on, and then there's an energy that you need to have, this to be in this state. And so the formula goes, I'm not going to go into the math now or the formulas, but at a certain time, I will say, this will actually collapse. And when it collapses, it actually creates what he calls proto-consciousness. So like a small, and I think the questions that Turtle have will be semi not answered, because I think I understand where you're coming from. So what is this consciousness? Can you measure it then?
Is it quantifiable?
So,
right.
Yeah, in terms of, can you put the finger on it in terms of, but that comes from a classical view of, is it a particle or something that you can observe? Can I observe it in a microscope or something?
Right.
Like in this case, we're talking small scale here, but, so you have, depending on the energy it takes for this, at a certain time, this will collapse. And objectively collapse when you have these quantum states. I'll be generic now. So you'll have this quantum this collapse of the wave function. I'm not sure if we can talk about this, because I would have to explain qualia. So if it collapses, so to say, so you look at the now I'm going to skip this. It's just going to confuse us, I think. So now we're going to get down to, okay, well, how does this consciousness mechanism meets the structures of the ORC-R, or when they meet, you kind of have ORC-R happening all of a sudden. So you have the brain in terms of structure. You have a neural network. You have neurons. Inside the neurons, you have these cytoskeletons, and inside those you have microtubuli, and inside those you have the microtubuli, and then you have the tubuli. And inside there you have the something called pi resonance, and that's actually where the quantum stuff is happening, so to say, to be a little bit generic. And that in terms of that maybe explains part of the question of Turtle, of where is it actually happening, and they actually measured down to this level, and we're talking nano meters or inches, whatever you want to call it. So you have this quantum computer that Penrose was looking for, and Hameroff gave it to him in a way. So because Hammers had the mechanism for consciousness.
You know what this looks like to me? Essentially, the consciousness is being created by this quantum computer inside of our meat sacks. Like this is essentially, if you put enough processing power into something, eventually it becomes conscious. Maybe that's part of, and because we have so much processing power in our brains because of these microtubuli that are there's a lot, right, in each neuron, each individual neuron. There are a lot of these microtubules.
Yeah, we just saw the 10 to the power of. So if you look at the size now here, this is nanometers, so 10 to the power of -9. So not observable by the eye, of course. So you have these quantum states that these pi resonance and then the tubuli that can happen, and they work across in symmetry. I can't explain probably really well, and I don't want to go into more detail because it's already, you see the topic is complex. When we did the first video, I freestyled on some of this, and I stayed very high level. Once you go down, it's difficult to keep it short and sweet, so to say, but it's my challenge to get better at this maybe. So you have this orchestrated object reduction in the microtubule. So you have this, I guess it's what's showing here on the left side, you have this superposition, and at one point, given the formula, so to say, by Penrose, in terms of there's a quantum gravity effect, this state cannot stay like this forever, it has to collapse. And when it collapses, you get this consciousness event, so to say, this bing, and then it continues. Right?
So give it enough time and enough processing power, that consciousness happens.
And we're not talking that it needs so much. It's just, this is on a small scale. This is not the whole brain doing something. This is bits of the brain creating this, so to say. I'm not, because you were saying, I don't need the whole brain to create a moment of consciousness. This is tiny pieces of consciousness, so to say, that can also be created. So you see in the bottom right, I think it's the same thing, just shown a little bit differently.
Which is very interesting to like someone with Alzheimer's. Do they still have consciousness, I guess, even if they're totally
actually
missing.
And then I skipped over this, but Hameroff actually talks. It's funny that you bring it up yourself, genius, in a genius way. Because he actually talks about how understanding all this, they understand Alzheimer's better because they understand, and I think it'll slide in here on this, what actually deteriorates and that causes Alzheimer's. So you have this tubules, they have this quantum state, they do whatever magic they do here, and then it collapses and you have these moments of consciousness. Now talking overall the full brain, I'm just talking, it doesn't take all of the microtubules to calculate something. It's even just regional, so to say, to calculate something in a neuron, for example.
We already seen what those one-celled organisms have the capability of doing. They have microtubuli as well.
Exactly. That was the answer earlier of how do they actually do it. This talks about frequencies.
I think Turtle was also asking about how this is measured, how they were able to, how can they measure, I guess like you've stated earlier, they've actually went down to this small stuff and there's been testing.
I don't need this. Then, okay, if you want to, let's go jump to this because you're curious about this. They have also quantum effects in plants. Sorry, I didn't change the heading here on this. I'll skip over I'll just mention it. I said that this is chemistry now on the biology. So there's benzene and consciousness, this whole topic that we talked earlier. So certain chemical material appears to affect the microtubules and then basically turn them off because they connect to it and then it kind of turns off. And that's how you can prove, and they're doing experiments on this now. They were given actually money, I think, a year ago. So, and the first experiments are coming in, and they prove that actually this is how it works. I'm going to skip this. Also this, in a way we talked about this is the neurons, pyramidal neurons. You have the microtubule structure in there, then you have the pathways through it. And that could be how it works. So here it's what Total was asking. So they actually, if you talk practical now, this is Anirban Pandyopat. I assume he's Indian descent. And Anirban, he liked the modeling of Hammerf, and he looked into the microtubule topic, and then used nanotechnology to actually attach 4 different nano electrodes to a microtubule structure. And then he stimulated 2 of them, and then the microtubules were good insulators, so that worked. But when they stimulate them with alternating current at different frequencies, they actually became conductive. So the resistance decreased, and they became highly conductive at a room temperature of 10 megahertz and 20 megahertz, and also at the kilohertz range. With that, he kind of showed that those are quantum effects. So they did experiments on a nano level, and you saw how small these microtubuli are, and basically put current on it and noticed their behavior, how at certain frequencies they seem to directly become conductive. I'm sorry. So that shows that if you have an electricity flow in the microtubules with these reactions, that's how you can see that this actually works. And then the gentleman used 2 megahertz to stimulate the buildup of microtubules, and he found that at 2 megahertz was the best frequency to actually grow microtubules. Remember that microtubules fall apart in Alzheimer's. So your question about Alzheimer's, actually, the reason you get Alzheimer's is because the microtubules fall apart. So this whole, maybe with certain frequencies, you can treat the brain and heal it, so to say, for Alzheimer's patients. That's might be quite useful in the future. And then he actually recorded the microtubule. So on the left here, you see actually, this arm here of the neuron, and you see the nano stuff coming in and connecting here. So he's using these nanoprobes to study this in the neurons, and he found something interesting, that a sequence of frequencies in the terahertz, gigahertz, and megahertz, and into the EEG range, that were actually coming from the microtubules. So you have different frequencies, so to say, for the different levels inside these structures, if that makes sense. So a microtubule bundle might run at the frequency of 100 hertz, and then a microtubule on this level and at these frequencies down to a level of very high frequencies in these dipoles, clouds, so to say. So they actually measured. So I think that's what you were asking, Turtle. They actually measured electrically, so to say, the frequencies where the microtubule seem to react. And there's actually, I don't have my audio turned on, so you probably won't hear any of that. So that's how it might look at the kilohertz range, and then I think going down in the megahertz range, you see, in a way, and I'm freestyling now, given that we're in the FreeStyle podcast here. This is different frequencies, and you can kind of see what functions there are possible inside. So it just went through, I'll start this again. if you see, it starts with kilohertz range. And it's actually playing now. And that might be outside where stuff is happening. So to say, this superpositions might be happening in the quantum effects and consciousness. Then you may have something in the megahertz, and then you see that this part of the microtubule is actually, doing things and vibrating or calculating. And then for the gigahertz, you have inside the structures these effects, and that's what they measured. And there's sound to it.
So it's almost like they were stimulating parts of the brain to see what's happening at a high level. This is at a small level where they were stimulating by putting electricity or hertz. Not one guy did electricity, but that's
electricity.
Electricity. Okay.
Yeah, electricity. And this is just one microtubule. So you saw, I think my camera went off. So this is just one microtubule. So if you go back to this, for example, so you see here, that's not one microtubule. This is actually this whole arm. But if you go to this experiment, and this is a visualization, so to say, on the right here, you see one microtubule, and then he put the nano diodes in here to measure. So did you actually hear that? No, you didn't hear that. Right? Okay, so I had this on. It's actually a hammer of talking. So that sound that he played, where they made an audio of the frequency, so to say, and you could hear the resonance of these microtubules. I'm gonna skip over probably most of this for now because I think the main points are made, and we're gonna get into. So. Maybe to sum it up, and then
that was good that you had. Sorry to interrupt. That's good that you had all these. You showed us all these experiments or stuff that was being done. Because if anyone wants to dig deeper, they could probably look. Where would you say you reference this work from, so people could dig a little deeper if they'd like to?
I would say go to my channel, and I will. I mean, on the slide, some of the things that. Where it showed, I'll go back here. I mean, you see in the bottom here, you see the reference to the study. Actually, for example, on here, I actually reference the study. So when people see the slides, they can use this in here.
I see. Good. Sorry about that. Good. Continue.
That's okay. It's a good question. I mean, it's also when I do this, I do try to put where people could look it up, because each of these like this slide or with this stuff where they measured, you can look up this 2 studies already, then all of a sudden you have 2 papers you can if you wanted to dig deeper, for example. Right. And it's almost like for many of the other things, it's the same thing where you actually you can dig down, and I like to put the source so that it's clear. I don't want to go into this but I'm going to skip over this and maybe wrap it up, and then we can jump around and ask questions. So go ahead.
Sorry, what part were you at there in the outline? Where were you at? Are you at the depth of confidence, theory of practice? Where are you at exactly?
The piece where I'm skipping over, where I'm ended up now.
Where are you at now? Yeah.
The piece I skipped, I think, was about level of consciousness and so forth, and I think I'm at the summary now.
Okay.
Yeah, actually, I am. It says on the bottom right in German summary.
What was this consciousness and evolution portion? That's a very interesting topic.
I just skipped over that. If you guys want to.
Yeah. Well, actually, Turtle, did you want to? Did any of that you talked about with the measurements? Help with any understanding? I mean, I know there's a little more.
It's just more questions.
Right.
Well, like I understand. I understand frequencies. Well, not. I mean, as any at a layman level. So it's like the microtubuli were. They would respond to certain frequencies or to the same frequencies, and they would also give off certain frequencies. What about the rest of the body, or what about the rest of the cells? Like, wouldn't they have their own unique frequencies? It still doesn't quite explain to me consciousness. Like it's not, I don't know. It just, for me, I feel like there's more to it. Like
there's I mean, yes, if you mean if I put if I don't know, I put just like two patches on my body and then see what I get. Do I get similar things? But I think the difference you have to make now. And so if we're flying through here, what's the best slide to use? If you look at if you remember the video where it shows the different frequencies and the different levels of the microtubules or structures of the different structures of the microtubules being active, so to say. The one thing that you don't get anywhere else is this quantum state. It's already difficult to achieve in the brain because it's wet and warm to have a structure that actually can create a quantum computer, which ultimately that's what the microtubules are, is already difficult. It's already a challenge, a feat to pull off. So I think you're poking at, okay, prove to me that it's actually the microtubules that where consciousness seems to happen, right?
I believe, I understand at a certain level here, the microtubule houses consciousness. But my question is, how does it create consciousness? So that's like, I understand the frequencies and all of these things. So to me, it still feels like that question isn't answered.
It doesn't house it. It creates it in the sense of that it creates these quantum superposition states. And then when the wave function collapses, that's when consciousness is created. In some sense, that's housing it.
Well, the proto-consciousness, the little pieces of all the proto-consciousness. But all of that collectively is consciousness as a whole.
Yeah, because there's structures in the brain that do this. And there's for sure not everything's understood. And I would argue, or I'd say, like you stated, this is a theory. I think it's pretty solid because they're starting to prove things around it. So the whole thing around, is it the microtubules? They have just, and I didn't put this in the lecture yet, but I wanted to look it up and put it inside because I listened to one of Penrose's talks that he gave recently, and they actually talked about this in Hammer of Two, where they said, because they've been granted money for studies, and this was picked out of many possible theories for consciousness. And it's strong. It's put this way: a strong indication that consciousness is happening in the microtubule.
Well, it's definitely
so when you say,
it's definitely a quantum computer, though, in those structures. They pretty much they understand that it's a quantum computer essentially inside of our body.
Yeah. So when you say it houses it, it creates it because it creates these superposition states on a quantum level. Then that has to collapse, which I showed earlier in one of the slides where it's like, okay, at a certain time it kind of has to collapse, and you have proto-consciousness, and then you have the orchestration of the brain, to create this experience, so to say, of our consciousness. And how it does this, it's not like it's physical laws, so it's quantum gravity. That's why it's objective.
You know what's even crazier? You talked about us being able to focus on something in another room and it become the outcome. It makes you almost think that, just like with the mycelium network with mushrooms and being able to communicate, trees being able to communicate using this mycelium network, it's almost like in a sense, maybe we do have some kind of impact on our environment from within that's not necessarily a physical state, but just way of being.
I didn't talk much about entanglement, but there's experiments where you can have an entangled photon or a photon split, and then the two are entangled, and then you could have measurements, them going through a filter or something, and then they either go through or they don't, and then this is apart with distance, and then the photons all of a sudden know instantly what the other one did, which the information can't travel faster than the speed of light. So it's kind of a conundrum. How do you explain that? And that's your point about that there is an influence. I mean, I talked in the first podcast where I was a guest. I talked about this. I think I talked about this. Like this is now no longer this org R. This is me spinning it off, so to say. If you have, and you can take that experiment as you mentioned, if you have this consciousness. Now, what is it? Is it a consciousness receiver, our brain? Is it a consciousness receiver? Is it a producer? Is it both? And what does that mean for, because we talked earlier, Penrose has explained that this is happening also in the universe, not just on the macroscopic level. This is, and there's a Italian scientist who has looked at OR and projected onto the cosmos in terms of Big Bang afterwards, and is our universe in a quantum state, and could that also produce consciousness, which all of a sudden you may have an explanation for, I don't know, you want to say it, God, the supernatural, whatever. I would just call it consciousness, also happening. So back to your point, maybe that's what I want, and that's why I feel strongly about it. But I think why would we not influence with our consciousness our environment? I mean, we clearly do. Everything's anyway interrelated. So, just look now. I'm actually talking to you across thousands of miles. So many things that needed to happen for, me buying this equipment. Somebody in whoever, China or South Korea, created this monitor. I bought it, Amazon delivered it, so forth. The interdependence and the interbeing, that's self-apparent or self-evident for me, so to say. So why wouldn't it be, why wouldn't it make sense, or it does make sense in my view, that our brain with our consciousness leaves an imprint, not just on other human beings. That seems clear because you interact and that kind of shapes over on the other side, but even on a quantum state level, to create some entanglement, so to say, with the space-time consciousness structure, so to say. Why not? Yeah, it makes sense to me.
I feel like it's just like, in that regard, it's like you did go by those things, but it was also because it was part of your interest, right? So it's like we have interests, and then obviously people with certain interests will just kind of like be able to connect one way or another. So I don't know if it's particularly like 100% related to quantum entanglement, but like I'd say it's like, if you're interested in playing soccer, you're eventually going to like go to a field to make yourself available so that you can go play soccer with other people who have the same interest. So to me, it's like, I don't look at it at that kind of level. To me, it's like, if I'm hungry and I go to a restaurant, I'm going to meet a bunch of other people who are hungry and they want to eat food. So it's like, I don't know if it's 100%. So to me, there's more questions than there are possible answers, I think, but I'm gonna keep asking anyways.
Yeah, so the latter bit was not or. So this where I say maybe, and what I just claimed, is our brain creating an entanglement that leaves something somewhere? Now we're clearly in the realms of speculation because I couldn't explain it.
Right. That was my fault.
Am I entangling something? Because the experiment I just showed, you have to do something very specific to create these photons that are entangled. Because that would mean that we're constantly also. So it's not. I fully understand, and I'm just, the reason that spin-off goes is because, and I think I talked about this in the other podcast, is you see the science is overlapping now, and if you look at it, consciousness has not been a big part of science, so to say, and you see science and also spirituality overlapping. And each have their explanations. And for this bit that I talked about now, OR, it shows that we start to understand more. Understanding that we have this microtubule where apparently that's where consciousness is quantum computed, so to say. And then received, or the information of the universe, reality, I would just call this perceived, because you have this quantum computer available to us. That is interesting, and that's like eye-opening. And then if you spin it further, well, I talked about this in the podcast, I think. Okay, our son died, what happens to, and then I can make it irrelevant of our son, but you die, what happens to my consciousness? Now, given what I said, okay, your brain's dead, so the imprints I showed about memory, those surely die, that's it. Right? Yeah, so I mean, that would be a materialistic view that you could have on also, if I don't want to make myself feel better about something continuous, like you were saying, I go to the restaurant, So you could also argue that way, if I die, and then out of this, try to spin it further and understanding also the complexity of the universe. That's when I try to spin off, and that's of course, then my fantasy realm maybe, but to attach it. But let's go back to maybe something that's better documented than observed, so to say, the OKR. So if you want to, but I would say maybe we skip the evolution part of things. While it's maybe interesting, I think ultimately it just states, if I would summarize it in 2 or 3 sentences, this proto-consciousness on a smaller level, when you have maybe cells like the parasemium or something, even in the primordial soup, like it says here in this slide, you could have proto-consciousness. It's like a feeling of good or bad, and then the preferred state maybe is good, and that's maybe how things evolved. By good states and avoiding bad states, this simple consciousness got more and more complex, so to say. That's, I think, in a nutshell, without going into some of the details.
And yeah,
so this
evolution tells you that the strongest survive, or the one most well adapted survives. So
yeah. Yeah, so this I had the slide open for a couple of times now. So OKR suggests conscious experience is closely linked to the fine structures of space-time geometry. Given that quantum gravity works also on smaller levels or on quantum states, and that consciousness could be closely related to the mode of action of the laws of the universe. I just said because of the quantum gravity. Consciousness is a sequence of discrete events. So it's not like a continuous flow, but it's discrete events given very high frequency, short time. But anyway, it's discrete events. And each of them is representing a moment of object reduction, quantum states. And by the way, interesting question. I didn't talk much about qualia. This, how is it that generally I see red and you see red and you experience it the same way? How is that level transported in the universe? Is this quantum state information, so to say, that I can
color,
receive?
right?
Yeah. As a simple example, for example.
Well, you would say it's light. Isn't it light that makes color? Doesn't that have a lot to do with why we see color?
Right, but why is it that in the brain there seems to be basic information, even like joy and anger or something, or the color red? Why is it that we perceive it the same? I mean, there's difference. You could see, and people would maybe have perceive different shades of red differently, but generally speaking, humans see red the same way. Why is that? There's this qualia on the bottom of it that you cannot. Yeah, you have to put this into your theory, so to say, to explain. So there's some topics that where OKR is maybe good or promising. It does takes into account a couple of things like the control and regulation of neural actions, transition from a pre-consciousness to consciousness, its non-predictability, the causality in terms of, you can actually state, okay, because of quantum gravity, that's the formula, that's how it works. Yeah, this whole superposition topic, a flow of time, is in a way because of these states. And it has this connection to space-time geometry, which I find highly relevant, because a lot of the theories, like the multiverse, so to say, it's like, I'm sorry, it's just there's some reality that we're feeling, and I think in this bigger picture of having this all explaining one theory, consciousness needs to be inside of that. There's some this was already 3 years ago, so there's some more. So there's some testable predictions that I won't go into, that they actually have been confirmed. So out of 27 have already been confirmed. I'm sure it's more. I would add at least one, which is that the anesthesia works on the microtubule, so that's where it appears to happen. Yeah, I talked about that there's conferences on consciousness. I will definitely, in the process of creating a lecture, look at some of this new stuff and also integrate some of the results from Penrose and Hamroff on this. So this was my thought here. OCR, what does it mean for me? Our brain is a quantum computer with an incredible processing capacity, and it clearly appears to be connected to the basic structures of the universe and behaves just like the rules are in the universe. Interesting area is the influence of thought, like you also just mentioned, or consciousness on the world. So, this experiment with a double slit. I already said this, consciousness has an important place, obviously, in the universe. It seems to be, to me, kind of natural constant, something that's there, just like dark energy or matter. It gives the consciousness gives, or OCR explains also then the experience of the quality of space-time in a way. What it also made me reflect about, this example of like these one-cell organisms, like I have a different level of awareness when I kill a fly on the wall, if I even kill it. Like typically, like if in the room in the house there's a wasp, they have they have priority compared to flies. For example, I take a glass captured and take it outside. Okay, there's good biology reasons we need wasps, but the point being, even an ant or something, you walk around on the street and we don't always look down, but I'm sure we stepped on a bunch of ants and killed them. This is also, why is that different than a human being being lost or killed? And so there's just a different level of complexity of consciousness. And then of course bodily there's difference, but the complexity of consciousness, I would argue, is the main difference. And that, to be clear on, okay, just because we have a big brain, so to say, with big capacity, doesn't make us better. Yeah, and I'm still excited about this area of science for sure, but in particular, and there's still to understand and to discover. And just like Turtle, I do have tons more questions. Like I'm still not clear, you have, okay, let's say this theory was right, and you have these moments of proto-consciousness. So some way, we can I get a feel for this? Can I see it? And resonance in the microtubule might be one way, but it's not very satisfying for you. You only want to see with our eyes and ears, so to say, or experience it with our senses.
Yeah, but I think there's the pieces that can't be explained right now. Like, I mean, you know what? If you can believe in God and believe in other stuff like that, I mean, those are things that you can't see. And this stuff that we're talking about not being able to see is literally you cannot see it. It is,
So
you can't even see
so
it.
it's not that I'm in absolute disbelief. Like, so in order for there to be, distinctions between what is true and not true, there has to be at least a certain element of skepticism, right? Because then we can filter certain knowledge to come to like an actual conclusion that yes, this is actually factual. Like this is something that actually exists, and it's not just hearsay. You know what I'm trying to say?
Yeah.
So
You're looking for the smoking
like
gun.
I'm looking for the evidence, right? So it's like there are like these technologies, like these the knowledge that Mr. Metzen like just poured on us today. Like for me, it's like, okay, I'm looking at these things objectively, right? I'm trying not to have any presuppositions that could potentially sway or influence me to be biased. So like I'm looking at it and I'm asking questions, and it's like, okay, is this satisfying enough for me, or is there something more that needs to be answered? So like I'm listening to it and I'm looking for the evidence. That's essentially why I'm asking these questions.
No, I understand. What I'm saying is there's going to be a point where maybe the theory of everything does happen, where science does meet religion or quantum. Maybe there is, because that's what Albert Einstein was looking for, was this theory of everything. He wanted to connect God to it as well, or he wanted to figure out how God had a part into it, and I guess that was why he was coming up with that theory. So yeah, it wasn't necessarily a criticism. It was a further explanation of there's just so much that we don't understand.
Yeah, and it's normal. I mean, and by the way, it's not like I didn't prepare for condensing the whole thing. So it's difficult to. You saw me going by that it's in a way a bit complex, and you have to abstract, like I do myself, the theories. So it's not easy to just even explain it. So I may have not also not done a good job explaining it. And of course, it's normal because you are critical. I don't believe stuff, so I also ask, and I'm also not. That's why I'm also still poking at it, and trying to understand it, make sense for it to make sense. And I've dug in read papers and so forth to understand it a bit deeper. And then it's also there then when I build my confidence about that, I say, okay, I'm going to talk about this not just as something that's promising, but something that where I say that's probably it. I mean, just the fact that you can turn off, so to say, a microtubule with anesthesia, and then that's actually what's happening when you are actually getting operated and put under anesthetics, and that seems to be clear that it's there. The exact okay, how does orchestration happen then in the brain? How does that then explain thinking? How does it explain memory? They've given some ideas about this, about how it's imprinted maybe in the brain. I mean, the whole orchestration in the org-or, that for sure I didn't understand it and I'm still curious about. And this whole thing of, like I said earlier, I mean, so what does that mean? Our brain is what? A processor, a receiver, a sender of consciousness? And how does it compare to the consciousness that also appears to be going on in the universe? Given, I think her name is Sizzy, the Italian, it's a woman scientist. How does that correlate? Yeah, so we were talking, being critical and testing theories, so it's quite normal. And I'll be honest, it's already daring for a layman in terms of science like myself to, try to understand this and then talk about it, because I think I talked about Neil, what's his name, deGrasse Tyson. Like he's doing one of his things that I like. One of the reasons I like him is because he does a great job of explaining complex stuff simply, so to say. And it's difficult, and it's I noticed that when you ask questions like Turtle did, for example, or yourself, then it's like, okay, I understand what he's trying to, and how do you explain that? How do you make this microtubule consciousness thing more understandable, so to say? How can you explain it in a different way that it's clear, so to say? Yeah, so that's quite normal. So, and also, this is FreeStyle Podcast, so I purposely I mean, I would like to prepare a little bit differently, just to maybe have, just 10, 20 slides, so to say, speak of, and not the whole enchilada here for most of the thing. But in any case, it was a good practice to go through because, it's like I said, I gave this lecture in an observatory to about 40 people 2 times, and it was less interactive because folks didn't ask questions in the middle, so it was in the end. So it is tricky, because this is not, and it's also, you have to even want to hear some of the stuff, Again, I hope your viewers on your channel will start looking at this and maybe also be able to grow your subscriptions and viewers, generally speaking, because it's, some might find this interesting, others might say, yeah, okay, well, so what? Yeah, it's somewhere in the brain, great. But I don't care about anything else. Why are you bothering with all these technicalities, And then maybe how to fix a pizza is more important. That's fine too, So yeah, so this was a bit on the theory. It connects to my first visit here on the channel in terms of some of the foundations for my claim, so to say. It talks about what I just talked about, kind of gives the foundation for topics around consciousness being a quantum mechanic effect and in the brain in this microtubule. So if you learned nothing, then maybe this is some key sentences here, and that's where that came from. So
I appreciate you coming on the show again. Did you have any final words for us, Turtle?
Oh no, I learned a lot. My head is spinning. I definitely want to deep dive more, and I'm looking forward to hearing more from Metzen for sure.
Yes, I mean both ways. I mean, I look forward to coming here because it's we're all trying to establish ourselves here in the YouTube universe, so to say. So I was happy to. I told Justin, early when he contacted me here that this was also kind of the universe calling on me and finally do what I wanted to do maybe a long time ago and take my stuff public in a way through YouTube. So I appreciate you taking me on. It also has transported me forward a quantum leap, to use this terminology. Still
Great show, by the way. Great show, Quantum Leap. Anyway.
Yes. The good old shows. Yeah, so thank you for having me. I hope your viewers enjoyed. Like and subscribe the channel, like they always say. So it helps the pair here to grow their viewers and for Google and YouTube understanding that the content is interesting. Feel free to comment. I think, like they always say, we do like to hear from the viewers what they think. Was it useful, or if they have questions on topics just like you both asked me. I'm happy to answer questions where I can.
Sweet. All right. I hope you guys like that content. Please like and subscribe for more. Also, we do podcasts, so check that out.
Also, you beautiful people, at 100 subscribers, we have a special giveaway. So stay tuned.